This short lesson concerns perpendicular bisectors of a triangle in the context of hyperbolic geometry. In Euclidean geometry, the perpendicular bisectors of each side of a triangle meet at a point. I got this figure from the Proof Wiki article, Perpendicular Bisectors of a Triangle Meet at a Point. I'll give you a link to this and the information to this video. Let's just take a minute to make sure we understand what that means. So a perpendicular bisector is a line that's perpendicular to a line of a side of a triangle. So AC, for example, has this perpendicular bisector, and it goes through the middle point. So it's perpendicular to AC, and it goes through the midpoint of AC. And then we have another one here, another perpendicular bisector of the triangle at CB, and the midpoint is G. And then we have a third one here. The midpoint of AB is E, and then the line is drawn perpendicular. So the theorem is in Euclidean geometry says that these three perpendicular bisectors meet at a single point here, F. In hyperbolic geometry, the perpendicular bisectors of a triangle fall into three different cases. We have them listed here in Theorem 48. The perpendicular bisectors of a triangle either intersect at a point, that's the case we saw for the Euclidean geometry, or are parallel with a common perpendicular, or are boundary parallels in the same direction. So an example of the second case here, when the perpendicular bisectors are parallel with a common and have a common perpendicular. So we see this line here is a bisector, and it's perpendicular to this side. This line here is a perpendicular bisector of this side of the triangle, and then this line here is a perpendicular bisector of this side of the triangle. These three lines are parallel, and they all have a common perpendicular, the line L. And I'll show you an example of the third case on the next slide. In this example, we have the third case in the theorem when the perpendicular bisectors are boundary parallels in the same direction as shown in the figure. So we have these three lines here are perpendicular bisectors of the three sides of the triangle, and they're parallel, and they're all going in the same direction. So they're asymptotic to each other, but they don't intersect, going down in this downward direction. And then the third case, which was listed first in the theorem, is where the three perpendicular bisectors intersect at a point. And that's also possible.